Okay, let's check your work on this last example. What we have is all of the variable terms are already collected on the left, constants on the right. Notice though that you did probably have to switch the order of these two terms. Then you had to divide everything by 3 so that we have a leading coefficient of 1. And then you ask yourself, what's half of 6 squared? Well, that would be 9. Add 9 to both sides. You've got your perfect square trinomial, so now you can factor it to be x plus 3 quantity squared, and that equals 24. Take the square root of both sides, but notice 24 is not a perfect square, so we need to simplify it. That simplifies to 2 square root of 6, and so we can just leave our answer as negative 3 plus or minus 2 square root 6. Okay. All right, so there's one more way we can use completing the square. And we can use that process to write a function in vertex form. Because remember, our vertex form of a function includes, oops, sorry, I wrote the wrong symbol there, a perfect square trinomial. Look at this. That's a perfect square trinomial. And what completing the square allows us to do is to write those so we can put it in the factored form. And then we can easily see where the vertex is of the function rather than having to do all of the work we did when we looked at section 5.2, where we found the axis of symmetry, substituted it back in. So this is just another way. So we're going to write these in vertex form and then identify the vertex. Now notice we're dealing with a function right now. So when I'm working with a function, I can't add 12 to both sides because the left side is the value y. And so instead of separating the constants from the variables by adding or subtracting, we're going to separate them by drawing parentheses. So we're using our associative property. So now I'm going to focus in on what's in my parentheses. What is half of 16? 8. What is 8 squared? 64. So now I'm going to rewrite that. So I have my x squared plus 16x plus 64. I've got that minus 12. Now can I just go around adding 64 onto functions? No, I cannot. That's not okay. But I also can't add 64 to the other side. So the only other option I have to keep this balanced and equivalent is if I just added 64 in these parentheses, I am going to do the opposite and subtract 64 outside of them. I'm going to factor and simplify, and I should be in my vertex form then. So f of x equals what multiplies to 64 and adds to 16? 8 and 8. X plus 8 quantity squared. Let's simplify 12 and 64. That would be negative 76. Now I have this in vertex form, so I'm ready to answer the next part of the question. Where is the vertex? The vertex, remember, this means that I'm going left 8 when I see that positive 8 in there. So left 8 would be negative 8 and then down 76. So this is my answer right here, both of these parts. The first is my vertex form and the second is where is the vertex located. We'll do 2 more together and then that'll be it for the videos this week. Okay? All right. So, similar to before, separate the variable terms from the constant terms. This time I'm using parentheses to do that. Second step was to have a leading coefficient of 1 though. So what I'm going to do is I am going to factor a 3 out of these parentheses. So I'll have my g of x equals 3 times x squared minus 6x plus 7. Now I can move ahead with completing the square. I ask myself, what is half of 6? That's 3. And what's 3 squared? 9. So I'm going to add 9. And now remember, to keep it balanced, I have to subtract on this same side. But think about it. Did I just add 9? I've got my distributive property at work here. I didn't just add 9. I added 3 times 9, which is 27. So in order to keep this balanced, what I need to do is subtract 27 at the end. That's going to be the trick. That'll be this little part here. Forgetting that 3 is where most of you will make your mistakes. You'll get examples like a letter A. You'll get them right almost all the time. It's the ones like this that will be your challenge. Okay, so watch out for that. All right, we're ready to write it in vertex form. So I keep my 3 there. What multiplies to 9 and adds to -6? -3. 7 minus 27 is -20. So there's my vertex form. Where is the vertex located? Well, I see a -3, so that's right 3. So +3, -20. So there we go, my vertex form and my vertex. We'll try one more together so then I don't have to just post an answer key. But notice right away, this one does not have a leading coefficient, so it will be simpler like the first one. So I will encourage you right now to pause the video, see if you can try it on your own, and then turn it back on, check your answers. All right, separate variables and constants. Now I'm ready to complete the square. I ask myself, what is half of 6? 3. What is 3 squared? 9. So x squared plus 6x plus 9. I've got my -7 there too. If I added 9 onto my function, I need to keep it balanced by subtracting 9 outside of those parentheses. Write this in factored form. X plus 3 quantity squared. -7 minus 9 is -16. Now my vertex. When I see a +3, it means I'm going to the left. So left 3 would be -3, down 16. That's the vertex. Okay, so to wrap things up, what formula do we use for completing the square? We take half of b and we square it. That's our formula. And what does completing the square allow us to do? It allows us to write a perfect square trinomial . And remember, a perfect square trinomial gives us that advantage of having a factored form that looks like this. And so we can solve using square roots. We can change a function into vertex form. So it becomes very useful for us. All right, I'll see you in class and hopefully in office hours this week. And I will look forward to chatting with you all then.